Assalamualaikum. We are from group 23. So let's see our design. Okay, this is a floor plan drawing, which is the pink one is our existing building. We have the building A and also the building B. Okay, the grey is the skirting, or we can call as a divider, and then this is the road. Okay, the yellow one is the primary beam. Okay, the red is secondary beams. The blue one is a slab, and then the green one is the column. So next, this is the detail of the drawing. Okay, this is a side elevation view drawing. Okay, and this is the cross section drawing AA. So yeah, before that, don't forget to subscribe, guys. Alia, ready?
Hi Anna, yes I'm ready. Hi, Assalamualaikum. My name is Alia binti Rosli. My matric number is CP190093. So I will proceed for the first element that we have to design is design of beam. So first, let's look at on the specification. As you can see, this is all the specification that we have to use in the design of beam. In this calculation, we use 6 meter long span beam. Next, let's look at on the material. We use FCK is 30 Newton per millimeter. This is because our concrete grade is C30 and FYK is 500 Newton per millimeter. We also assume that diameter bar is 25 millimeter and length is 10 millimeter diameter. And for the overall size, is D times H is 300 times 500 millimeter. Next step is find the C minimum due to durability, fire and bond. First is C min due to bond is 25 millimeter based on our diameter bar, and C min due to durability based on structure class is 35 millimeter. And last, C min due to fire resistant, refer table 5.4, and we get the answer is 28 millimeter. To get the answer is C nominal, choose the higher value of C min plus 10, and we get the answer is 45 millimeter. After that, go to the loading and analysis. Based on our characteristic permanent and variable action, we got the answer of shear force is 141.8 kN per meter and bending moment is 211.77 kN. And last from me is main reinforcement. First, we find the effective depth is 408 mm and D prime is 68 mm. Next, calculate the embal. Since the embal is greater than bending moment, compression reinforcement is not required. Next, find the value of X is 148.9 mm and Z is 348.44 mm. And from that, we can get area of tension is 1398.68 mm per square, and refer table A, we use 1964 mm for 4H and 25. And for the last, we have to find the maximum and minimum value area of tension. AS min is 185 mm per square and AS max is 6000 mm per square. Alright, that's all from me. Thank you. I will pass back this presentation to Liana.
Alright, Alia, thank you. Okay, my name is Nolena Meti Mazani. My matric number CP106. So let's continue the calculation for design of beam. Okay, the shear reinforcement. The design shear force, we get 141.18 kN per meter. So the concrete strut capacity, we use the angle theta is less than 22 degrees. So the theta, we get the answer 6.94 degree. Okay. So the shear length, we get the SW over S, we get a 0.36, which is we try the length R10H10, SW equal to 157 mm square. Okay, the spacing, we get a 436 mm. So the max spacing, S max, we get the answer is 306 mm. So therefore, we use the H10 is 175. Okay, the minimum length, SW over S, we get the answer is 0.2 mm. 0.26 mm. So try length H10, SW 157. Okay, we get the answer of spacing is 604 mm. So it is more than 0.75t, which is 306 mm. So we will use the maximum of H10 is 300. Okay, the shear resistance of minimum length, B min is 208 kN. So the length arrangement X is 1.42 m. Okay, the additional longitudinal reinforcement. Okay, for the additional tensile force, we get the answer is 176 kN. So the MED equal to MX exact, we get the answer 608 kN. Okay, for the additional longitudinal reinforcement, yes, we got the answer 4085 mm square. Okay. Okay, next we go to the deflection. P equal to 0.011. P naught, we got the answer 0.0055. So the factor for structural system, we get the answer L over D is equal to 15.11. So therefore, basic span effective type ratio L over D is equal to 15.11, Modification factor for the span less than 7 mm, so you get the answer is equal to 1.0. So modification factor for steel area provided, you get the answer is 1.46 mm square is less than 1.5 mm square. Therefore, allowable span effective depth ratio, L over D allowable, you get the answer is 22.06. So the actual depth span effective, L over D actual, you get the answer is 14.71, which is less than L over D allowable. So the answer will be okay. Okay, the cracking. Limiting crack width W max we get is 0.3 mm. So the steel stress, we get the answer is 168 Newton per mm. So the max allowable bar spacing, we get the answer 85 mm. So which is less than 200 mm. So which is the link and reinforcement is fit into the concrete. Okay, so the answer is really okay. So next we go to detailing. That's for the detailing. So this is link and this is the reinforcement. We will use the reinforcement for H25 and then the link is H10. Okay, so that's all from me. Alright, Irene will continue. Okay, Irene, go.
Assalamualaikum, my name is Irene Arisakis Cina binti Ahmad Zamili. My match number is CP190094. So I will continue my part, which is slack. I take a half of part of slack only. Both of the span for LY and LX are 6000 mm. How to know we use one-way or two-way slack? For our design, we use two-way slack because it is less than 2.0. R is 6 meter, B 1000 meter, H 200 mm after do L per H. Load GK is 1.55 kN per meter square. For QK is 5 kN per meter square. Base table 1.6. Design life only 50 years. Suitable base the table 2.1. 5 resistant REI 240 4 hours. Exposure classes SG3 because based on the table. For unit weight 25 kN per meter square. Nominal concrete cover C0 is 50 mm, FCK 30 Newton per millimeter square, FYK 500 Newton per millimeter square. Diameter bar is 32 mm. All of this refer to the table. Design action for slab self-weight is 5 kN per meter square. Include GK is 6.55 kN per meter square. ND can consider equal to 16.34 kN per meter square. Refer table 3.12. So the moment for short span MSX and long span MSY based on formula in table 313, we got 36.47 kN per meter. So next presenter.
Okay, thank you, Ying. Okay, Bismillahirrahmanirrahim. My name is Ramatu Adawiyah binti Awang CP190033 and I will continue on my part, which is main reinforcement. Okay, in main reinforcement calculation, we need the effective depth, which is dx and dy, where the dx we got 134 mm, meanwhile the dy we got 102 mm. Next, for the short span, we need the moment of SX is 36.47 kN per meter and K is equal to 0.07, which is less than K val 0.167. So, we can assume that the compression reinforcement is not required. Furthermore, we get Z 0.93D, which is less than 0.95D. And the area of steel, in this short span, we got 672.76 mm square per meter. So, we can assume that we will use H12 150, where the area is 754 mm square per meter. Next, for the long span, the moment SY is 36.47 kN per meter and the K is equal to 0.12, which is less than K val 0.167. So, we also can assume that compression reinforcement is not required. Then, for Z, we got 0.88D, which is less than 0.95D, and the area of steel is, in this long span, we got 934.04 km square per meter. So, we also can assume that we will use H850, where the area is 1005 mm square per meter. Okay, next, for the minimum and maximum area, we got 202.07 mm square per meter for AS min, and AS max is 8000 mm square per meter. The next step is to find the shear in this slab. We got now 49.02 kN per meter for the maximum design of shear force. And for the K, we got 2.22, which is more than 2.0. Then for P1, we got the answer is 0.0056, which is less than 0.02. Meanwhile, for VRDC, we got 82 kN and V min is 73 kN. So we can conclude that VRDC is greater than VED. Okay, next we can proceed to the deflection calculation. Okay, the percentage required tension reinforcement is P equal to 0.0050. Meanwhile, PO is 0.0055. So when P is less than PO, so we have to use equation 1 and we got 20.59. The modification for the span less than 7 meter is 1 and the modification of steel used, we got 1.12 less than 1.5. Therefore, LD allowable is 23.06 and LD actual is 44.78, which is greater than LD allowable. Lastly, for the cracking, the slab thickness is okay and the maximum spacing for slab is 400 mm and the maximum bar spacing is 745 is greater than spacing max for slab. So it is acceptable.
Okay, thank you, Atul. Okay, my name is Islan Shakiri bin Ali. My metric number CP190071. Okay, I will present about column for this project. This is a specification for this project. Okay, for durability, bond and fire resistance, CMIN equal 20 mm, CMIN dark equal 35 mm, ASD equal 35 mm, CMIN equal 90 mm, design for deviation 10 mm, so xenon equal 45 mm, so use xenon 45 mm. Design moment MED, MO2 equal 45.56 km, mean equal 240 km, so MED equal 45.56 km. For reinforcement, D2 equal 61 mm, D2 per hash equal 0.20 and per BH FCK equal 0.53 and M per BH square FCK equal 0.07, AS equal 900 mm square. Okay, AS mean equal 276 mm square. For AS max equal 3000 mm square. Length equal 5 mm, so I take 6 mm. SV max equal 240, so use S6 240. But AS section 300 mm below and above beam at lip pin joint SV max. So 0.6 multiply 240 equal 144 mm. So use H6 144. Okay, use for bar, use for H20 and to H12. Okay, thank you for me.